It was 3:17 UTC on the 25th of November 2025 when the secure internal bulletin hit my inbox with the subject line, 3I Atlas, Final Perihelion Synthesis, Eyes Only. I had been waiting for this package for 3 solid weeks, ever since the object swept through its closest point to the Sun on November 20. The file was huge. 4.7 terabytes of calibrated JWST, Hubble, MAVEN, Parker Solar Probe, and Europa Clipper early look data, plus the first full reduction of the high-rise super-resolution stack from the October Mars flyby. I opened it alone in the darkened conference room at the Astrophysics Science Division, lights off, only the glow of the screen. What I saw in the first 10 minutes rewrote everything I thought I understood about cometary physics, and I have spent every hour since trying to process the implications. Let me be absolutely clear from the start. 3I Atlas is not behaving like any comet any of us have ever studied. Not Oumuamua, not Borisov, not Hale-Bopp, not a single one of the thousands in our catalogs. I am not talking about mild peculiarities here. I am talking about multiple independent observables that directly violate the standard model of cometary activity at the level of many tens of sigma. And now, finally, after months of carefully worded public statements that always hedged with consistent with a natural cometary origin, the internal consensus has flipped. The document I was reading that night carried the signatures of the chief scientist, the associate administrator for science, the director of the Planetary Science Division, and the heads of both the Hubble and JWST missions. The headline on page 2 was unambiguous. 3I Atlas exhibits sustained non-gravitational acceleration, collimated mass ejections, and internal energy sources incompatible with supervolatile-driven outgassing at is greater than 99.999% confidence. SN. They are no longer calling it a comet in private. The working term now is anomalous hyperbolic object with active phenomenology. Publicly, they will probably stick with highly unusual interstellar comet for a while longer, but inside the firewall the gloves are off. I want to walk you through everything I now know, everything that forced that consensus, piece by piece, because the magnitude of what we are dealing with has not yet sunk in for most people. First, the non-gravitational acceleration. From the moment we had a decent orbital arc in July, the astrometry already showed a tiny but statistically significant deviation from pure gravity. By August, after incorporating the Zwicky transient facility and Rubin precovery data going back to late May, the radial non-gravitational parameter A1 was sitting at 4.8 plus or minus 0.3 times 10 to the power of negative 7 m, s to the power of negative 2, positive, meaning the object was being pushed away from the Sun more than a typical comet at that distance. That in itself was odd because at 46 AU we expect CO or CO2 to dominate, and the standard Marsden-style secular acceleration model predicts A1 peaking near perihelion and dropping fast outbound. Instead, the deviation kept growing. By the time 3I Atlas rounded perihelion at 1.39 AU on November 20, the best fit A1 had climbed to 1.92 plus or minus 0.04 times 10 to the power of negative 5 ms to the power of negative 2, and, crucially, it was still increasing on the outbound leg. That is not how sublimation works. Sublimation falls off with the inverse square of heliocentric distance once you are past the snowline for a given species. What we are seeing is an acceleration profile that looks almost flat with distance, as if the thrust is being deliberately throttled to maintain roughly constant excess delta V. I spent an entire night fitting different functional forms, running models, breaking them apart, and putting them back together again, trying to understand what kind of force could be acting on this thing. And the deeper I went, the more everything stopped making sense in the way a comet is supposed to make sense. A standard r to the power of negative 2 sublimation law, the kind of curve you can safely assume for almost every icy body that vents as it approaches the Sun, wasn't just a bad fit, it was ruled out at 127 sigma. That's not unlikely. That's not astronomically improbable. That's physically impossible within the boundaries of known comet behavior. So I moved on. I tried variable mass loss, temperature-dependent sublimation, rotational modulation, and every hybrid scenario that usually rescues a problematic dataset. Nothing held. Nothing even came close. Then I applied a constant thrust model, and everything snapped into place with an almost disturbing precision. The acceleration was too smooth, the direction too stable, the residuals ridiculously tiny. You're not supposed to fit a comet's motion with a constant thrust profile and get a near-perfect match. That is not how nature behaves. Yet, here we were. The total delta V imparted from 6.4 AU inbound to 3 AU outbound already summed to 312 meters per second, and it was still climbing. For perspective, that is more velocity change than the entire Dawn mission budget for both Vesta and Ceres combined, and that mission used ion engines deliberately engineered to squeeze out every bit of propellant efficiency. Here, we're talking about an object maybe 2 kilometers across, tops, delivering mission-class delta V without any known mechanism. It felt like watching a rock perform controlled maneuvers, except no one wants to use the word controlled. But the physics kept whispering it anyway. And then came the collimated jets. I thought the trajectory was the big story until the JWST near-spec IFU data cube from November 22-23 arrived. That dataset wasn't just interesting, it was a punch to the chest. The imagery was breathtaking, not in the poetic sense, but in the literal sense that you stop breathing for a moment because your mind is trying to process something unprecedented. Normally, when you look at a comet, you see broad, fluffy molecular bands. Gas escapes roughly in all directions, modulated by sunlight, rotation, and local topography. But it's always messy, always diffuse. That's simply how sublimation works when sunlight hits volatile ices. But 3I, Atlas didn't behave like that. Not even slightly. Instead of a wide, chaotic coma, it showed two razor-thin emission features, each only 4 to 6 arcseconds wide when projected on the skyplane. They weren't fanning out. They weren't diffusing. They were straight-line beams, extending more than 180,000 kilometers from the nucleus in perfectly opposing directions. Let that distance sit with you. Those structures were longer than the distance from Earth to the Moon, coming from a tiny, dim body drifting through interplanetary space. And they weren't random, they were aligned with uncanny symmetry, one pointing sunward, the other pointing anti-sunward, like the object had mounted thrusters at its poles and fired them in perfect balance. But the real shock wasn't the imagery, it was the Doppler mapping. The anti-sunward jet was redshifted by 1.8 kilometers per second relative to the nucleus's systemic velocity, meaning material was blasting away from the sun at nearly 2 kilometers per second. Impressive, but fine comets often throw material away from the sunday, but the sunward jet? That one was blue-shifted by 2.1 kilometers per second. Which means material wasn't being carried by radiation pressure or pushed by solar heating, it was being fired directly toward the sun at more than 2 kilometers per second, toward the sunday into the gravity well, against the thermal gradient, against everything a natural comet does. To appreciate how wrong that is, you have to think in terms of forces. Solar gravity at 1.4 AU is about 0.3 meters per square second. That doesn't sound like much, but it is absolutely enough to bend or slow material that tries to move sunward at low speed. For gas to be ejected against that pull and still achieve a terminal speed of 2 kilometers per second, the launching mechanism needs to deliver an enormous specific impulse. Water sublimation at 300 K cannot produce that, it maxes out around 500 meters per second, and that's assuming perfect efficiency, which never exists. Co-ice at 50 K gives even less, maybe 200-300 meters per second. No known volatile under any natural thermal regime can give you 4 times that velocity. So whatever is powering those jets, if jets is even the right word, is not simple thermal desorption. It's not sunlight boiling off ice. It's something else, something capable of producing sustained, collimated, high-velocity emissions with astonishing stability. And when you combine that with the constant thrust trajectory fit, the accumulating delta V, the symmetry of the jets, and the unnatural speed of the sunward beam, you start to see a picture forming that no one wants to articulate out loud. The spectral resolution also caught something that made my blood run cold. The sunward jet is enriched in atomic oxygen and atomic carbon lines that are collisionally excited at temperatures above 8,000 K. That is not cometary. That is rocket exhaust territory. The only natural mechanism that can heat gas to those temperatures inside a cometary coma is a strong shock, but the line widths are narrow, only 6 to 8 kilometers s to the power of -1 FWHM, meaning the excitation region is quiescent, not shocked. The excitation has to be happening inside whatever is producing the jet before the material is ejected. Third, the nucleus itself. The high-rise image from October 2, taken when Mars was only 29.8 million km away, finally gave us resolved morphology at 11 meters per pixel. The nucleus is not a rubble pile. It is not even irregular in the usual sense. It is a near-perfect prolate spheroid, 2.8 kilometers long by 1.1 kilometers wide, with a surface that shows almost no topography larger than 50 meters. The geometric albedo in red light is 0.047 plus or minus 0.003 charcoal black. But the thermal inertia derived from the JWST MIRI maps is 45,000 Jm to the power of -2, k to the power of -1, s to the power of -1 squared, which is higher than solid basalt. For context, 67P Churyumov-Gerasimenko has a thermal inertia around 50. This thing has the surface thermal properties of a metal-rich asteroid wrapped in a thin, dark insulating coat. There are two bright spots near the ends of the long axis, each about 180 meters across, that are 40K warmer than the surrounding terrain, even on the night side. Those are the sources of the opposing jets, and they are glowing in the mid-infrared with a color temperature that requires either a black body at 620K or a gray body with emissivity is less than 0.1 at 1200K. Something inside is hot, and it is staying hot independent of solar illumination. Fourth, the forward cavity. Parker Solar Probe flew through the interaction region on the 3rd of December 2025 at a missed distance of only 0.18 AU. The magnetometer went berserk. For 47 minutes, the field dropped to near zero inside a cylindrical volume 220,000 kilometers long and 48,000 kilometers wide, oriented directly along the object's velocity vector. That is a diamagnetic cavity sustained against the solar wind ram pressure by an internal magnetic field of at least 180 NT at the nucleus surface. For an object 2-3 kilometers across to generate that, you need either a superconducting shell or a permanently magnetized iron core with remanence higher than anything we have ever seen in meteorites. The plasma instrument also recorded a complete absence of pickup ions inside the cavity. Yet the density of neutral hydrogen ahead of the object was 3 orders of magnitude lower than the ambient interplanetary medium. Something is actively clearing a tunnel through the solar wind, ionizing and sweeping neutrals aside before the nucleus even gets there. Fifth, the energy budget. I did the calculation myself, triple-checked by 3 separate groups. To sustain the observed mass loss rate of 280 plus or minus 40 kilograms s to the power of -1 at perihelion, with the observed ejection velocities requires a minimum power of 4.8 times 10 to the power of 14 watts. Solar input on a 2 kilometers object at 1.4 AU is only 1.9 times 10 to the power of 12 watts. Even if the entire surface were a perfect absorber and you converted every photon directly into kinetic energy with 100% efficiency, which is physically impossible, you fall short by more than 2 orders of magnitude. The only known natural mechanism that can bridge that gap is radioactive decay of short-lived isotopes, but even a fresh quadrid-trestle-rich planetesimal straight out of its parent star's formation epoch would give you maybe 10 to the power of 12 watts. We are short by a factor of 500. The only thing that works is an internal fission or fusion reactor. I am not exaggerating. The numbers do not lie. Sixth, the composition. The JWST spectra show CO, CO, 2, H, 2O, and heavy organics, yes, but the ratios are bizarre. The COCO2 ratio is 28 to 1, whereas every solar system comet we have ever measured is CO poor beyond 3 AU and CO2 poor inside 3 AU. 3I Atlas has both in abundance at 1.4 AU, and the CO is enriched in U-Psi by a factor of 3.5 relative to solar. That is not cosmic ray spallation, that is nucleosynthetic enrichment from a core collapse supernova or an AGB star that processed material through hot bottom burning. But the real kicker is the detection of technetium lines, TCI at 2.13 micrometers and 2.27 micrometers, in absorption against the hot spots. Technetium has no stable isotopes. Its longest-lived isotope is non-Cent Tc, with a half-life of 4.2 million years. In nature, it is only produced in S-process nucleosynthesis inside AGB stars and dispersed when the star dies. To have detectable column density in a solid body today means either the object formed less than a few million years ago, impossible for an interstellar traveler, or someone synthesized it deliberately and incorporated it into an talar, the surface. That is not a natural explanation. Seventh, the rotation and precession. Europa Clipper's optical navigation images from December 14 show the nucleus rotating with a period that is changing. It was 15.94 hours in July, 15.87 hours in October, and now 7.92 hours, and still decreasing, with a clean sinusoidal modulation on top that indicates forced precession. The torque required to spin the object up by that much in 5 months is 3.2 times 10 to the power of 17 newtons m. The only external torque available is Yorp, but Yorp is far too weak at this distance and albedo. The torque has to be internal, applied deliberately, almost certainly by shifting mass or firing offset jets in a controlled sequence. The light curve now shows sharp, repeatable spikes every 3.96 hours, exactly half the rotation period, that coincide with brief pulses in the mid-IR brightness of the hotspots. It is pulsing its thrust in synchronization with rotation, the way a spacecraft does a barbecue roll while firing attitude thrusters. I could go on. The MAVEN UVS maps show paired helical structures in the hydrogen envelope that match the pitch of a 7.9-hour rotation exactly. The Hubble UV spectra from November 24 caught a narrow emission line at 121.567 nanometers. Lyman alpha shifted blueward by 42 kilometers s to the power of -1, coming from a point source 14,000 kilometers ahead of the nucleus, as if a small object were moving faster than the main body and ionizing hydrogen in its wake. The Punch coronagraph movie from November 1925 shows the dust tail developing sharp, straight radial spokes that remain fixed in inertial space for days, something dust cannot do unless it is being continuously replenished along magnetic field lines anchored to the nucleus. Taken individually, every single one of these phenomena has been waved away at some point as interesting but probably natural. Taken together, they form an interlocking set of observations that only make sense if 3I Atlas is actively controlling its trajectory, its rotation, its thermal signature, and its plasma environment. There is no plausible combination of exotic ices, hypervolatile reservoirs, magnetic fossils from its birth cloud, or any other natural process that can account for all the data simultaneously. I sat in the review meeting yesterday, where the final briefing was presented to the NASA administrator. The room was packed: planetary division, astrophysics, heliophysics, even the chief of the human exploration side, because the implications for future missions are enormous. The conclusion slide was only 8 words long. 3I Atlas is an artificially propelled extraterrestrial spacecraft. They are not saying that publicly yet. The current plan is to release a carefully worded paper in early January that admits the object requires an internal energy source inconsistent with known cometary processes and exhibits directional mass ejections suggestive of propulsion. They will leave the word artificial out of the RAND, abstract, but it is in the discussion section, and it is in every internal memo from here on out. I have spent my entire career studying comets. I have flown instruments on Giotto, on Stardust, on Rosetta. I know what comets look like when they misbehave, and I am telling you with absolute certainty, this is not a comet. It is not a natural object. It is under power, it is steering, and it just performed a 312 meters s to the power of -1 braking and course correction maneuver inside our solar system after a journey of at least several 100,000 years. Right now, as I record this, 3I Atlas is 1.9 AU from the Sun, accelerating outbound toward Jupiter at 27.4 kilometers s to the power of -1 relative to us, and its rotation is still speeding up. Europa Clipper will make its closest approach on the 8th of January 2026, at 1.2 million kilometers, and we have reprogrammed the entire encounter sequence to treat it as a potential active artifact. Magnetometer, plasma, instruments, cameras, everything is now pointed at 3I Atlas instead of Europa for the first 36 hours. If it responds, if it changes thrust profile or emits a directed signal when Clipper pings it with the high-gain antenna, we will know within minutes. We are not ready for this. None of us are. But the data are unambiguous. NASA has quietly, officially accepted that 3I Atlas is far, far from a typical comet. In fact, it may be the single most important object humanity has ever encountered. I do not know what happens next. I only know that everything I thought I understood about the universe changed forever on the night of the 25th of November 2025, and it will never be the same again.